The air compressor, whether belt or gear-driven, that develops the pressure and supply not only for the brakes, but on some applications the suspension, windshield wipers, steering assist, and air-driven starters as well. The compressor develops a regulated system pressure between 110 and 130 psi through the use of one or two pistons in cylinders that draw air through an unloader or reed valve on the intake stroke and discharge compressed air through the discharge valve on the compression stroke. The reed valve consists of a metallic wafer that opens or closes when an outside force acts on it. Unload valves are spring-loaded valves that seal off passages inside the compressor when an outside force acts on it. The compressor is regulated by a governor that uses an unloader signal line from the supply tank to keep the unloader valve in the compressor head open when pressure reaches the cut-out value. When pressure drops to the cut-in value, which is a maximum of 25 psi below system pressure, the governor allows the reed valves to close, and the air compressor is allowed to once again pressurize the air charge to the supply tank. The pistons, bearings, and cylinder walls of the compressor are lubricated by an oil feed line from the engine. Superheated air passes from the discharge port of the compressor through a desiccant dryer or an air cooler on the way to the supply tank. When hot air cools, moisture is formed, so the dryer or heat exchanger uses a purge valve that is open to the atmosphere when the governor sends the unloader signal. Oil from a failed compressor can destroy the desiccant and enter the brake system. Oil and water contamination require the system be cleaned and flushed, or other parts of the system will be damaged. Refer to the OEM maintenance intervals. Moisture that is not removed by the dryer or heat exchanger will collect in the supply tank. Some supply tanks have an automatic drain, while others are manual. The supply tank should be checked and drained daily as part of the driver's pre- and post-trip inspections. Air dryers and heat exchangers do not completely guarantee a dry air system. Moisture can still be produced in the supply tank, primary and secondary air tanks, which should also be drained. In the rare case of a governor failure, the supply tank has a pop-off valve that will open at 150 psi and vent to the atmosphere. A continual operation of the pop-off valve indicates a problem with the governor or unloader assembly. An incorrectly adjusted governor may also be the cause. A governor can be checked by installing a pressure gauge on the supply tank and bleeding the pressure in the tank down to 60 psi with the engine running. A master gauge or the vehicle's dash gauge can be used to measure governor cutout pressure. The governor pressure can be adjusted by loosening the lock nut and turning the adjusting screw to adjust the cutout pressure to the exact specification for the vehicle. There is a 20 to 25 psi internal pressure spring that regulates the cutout and cut-in pressure window inside the governor. Adjusting the cutout pressure is the only external adjustment on the governor. Air from the supply tank is routed through hoses to the primary and secondary air reservoirs to await demand from the treadle valve or foot valve to engage the brakes. Air reservoirs on trucks are pneumatic pressure tanks that have a corrosion protection coating on the inside walls. Tanks should never be welded as the interior coating will be destroyed. Leaking tanks should always be replaced. The size of the air tanks is based on the ability of the supply, primary, and secondary system to completely fill the brake system to 3 times the volume of its combined capacity. Failure to achieve this build-up pressure indicates a problem with a worn compressor, a loose drive belt, a defective compressor unloader assembly, a supply circuit leak or restriction, or a defective governor.